Today we're going to be looking at topic 12, finding the volume of similar figures. Similar means that they're almost the same, they're the same shape but not the same size. One is generally smaller than the other one. So when we did this chart, and we normally said EE, area squared, and volume cubed. Now when I did that, what that means is if I put any two numbers at all in the world, like I'm just going to use A and B because they're variables in this column, I would square those to go here and cube them to go here. Now if I pick any number in the world, I'm going to pick a 3 and a 7. Now what am I going to do to this to move it here? I'm going to have to square it, and I get 9 over 49. Now to move it to here, I don't ever start in my area. I always start with everything else, and I move this way over here, and I say 3 cubed, which is 27, over 7 cubed, which is 343. So that's how I fill in the chart. So let's look at the first example. In the first example, they gave us this nice chart, so I'm going to go ahead and fill in EE, area, and volume. Now it says two similar cylinders have heights in the ratio 2 to 5. So if I look at heights, I ask myself, does the word height have area in it? No. Does the word height have volume in it? No. So where's it going to be living? Everything else. So 2 to 5 goes under everything else. Now how do I move it to area? I have to square it. And then how do I move it all the way to volume? I cube it. Now, I am a math teacher, and I've been doing this for a while, so I do know that it's my perfect squares and cubes. But let's say you didn't. In my calculator, don't forget, I can always put in 2/5. And then if I want that whole thing squared, I can hit x squared, and it'll give me 4 over 25. I can also do the same thing. Let me quit that. Alpha y equals, to give me my fraction, I'm still going to use 2/5. And this time, under math, I'm going to cube it, which is number 3. And I get 8 over 125. Now that I have that, I'm going to look at something different. Let's look down here. This problem deals with the same chart. And it says, the smaller cylinder has a radius of 6 centimeters and a height of 8 centimeters. What is the volume? Oh, well, let's look at our formula sheet. I pulled my formula sheet picture up, and volume is pi r squared h. So let's go ahead and find the volume of the smaller cylinder. And it's volume equals pi r squared h. I know that the radius is 6 and the height is 8. Now, just like before, I'm going to actually just do 6 squared times 8. My 8 looks like an R, but 6 squared times 8. And let's see what we get. Oh, it's a 5. 6 squared times 8 is 288. So my volume of the smaller cylinder is 288 pi. Well, if I wanted to multiply that out, because maybe my answer does have a pi in it, maybe it's already been multiplied through, I do that in my calculator, and I get 904.8. By the way, the units on this were centimeters, so I'm dealing with centimeters cubed. Don't want to forget that. So those are my two volume of the smaller cylinder. Well, that's not what it's asking me. It's asking me for the volume of the larger cylinder. So I'm going to have to go up here to this lovely chart and look at my volume ratio. So what does my volume ratio do? It helps me set it up. 8 over 125 equals, now which one do you think is the smaller cylinder? Where is this 288 pi going to go? On the top or the bottom? Last time I checked, 8 is smaller than 125, so the smaller one is on top, smaller over larger. So this 288 pi is going to go on the top, and I'm looking for the volume on the bottom. In order to solve this, I'm going to cross multiply. I'm going to get 8v equals 125 over 125 times 288. Let's see what that is. 125 times 288. I get 36,000. Now, to solve this problem, and I don't want to forget my pi, right, because I didn't add it in, so it's just sitting out there. I divide by 8. So let's see what that does for me. And I get 4,500. So the volume of the larger cylinder is 4,500 pi. Now, they might put the answer in that form, or we can just multiply it by pi to get my decimal approximation. And my volume is 14,137.2. And the units on this are centimeters cubed. So these are my two answers. We've done this before. The only difference is we actually had to find the volume of the smaller cylinder. They didn't give it to us. Now the next two are kind of a horse of a different color. It says, if the height of the smaller cylinder increases by a factor of 4, what factor does the volume increase? Well, if I look at that formula sheet and I look at actually what the formula says, it says volume equals pi r squared h. It's telling me that the height increased, nothing else. It increased by a factor of 4. Factor means multiply. So if my height, and only my height, is multiplied by 4, what's going to happen to this entire thing? The whole thing is going to be multiplied by 4. Now, if I'm not sure of that, I know the smaller cylinder's volume is 288 pi. So I could quickly just increase it and see what it is also. Volume equals pi, r is still 6, and height, instead of being 8, it's 8 times 4. So if I put that in my calculator, once again, I'm probably not going to put the pi in, but 6 squared times 8 times 4, I get 1,152. Now, how does it compare? How does it increase? I'm going to take that 1,152 and I'm going to divide by 288. Don't forget I have pi, but the pi's are going to cancel because it's pi over pi. And when I do that in my calculator, oops, 1,152 divided by 288. What do I get? Oh, if I put it in right, 1,152 divided by, this is being very difficult right now, 288, I get 4. So that's how I know that I'm correct. That's kind of like my little check mark. So if worst comes to worst, especially on an untimed test like the SOL, I can always plug it back in. I'm not going to show you that for this. So let's see. I have my formula. So where am I putting in the 4 now? It says the radius. So if I take this,
Mr. Morgan,
and I say, where's my radius? It's here. So what do I do to my radius? I square it. So I'm going to take that 4 and I'm going to square it. And when I square it, I get 16. So what's my factor? Is 16. So when they take a formula like volume and they only increase one aspect of it, like the radius or the height, I need to see what happens in the formula to see what it's going to increase the whole thing by. It's not as easy as putting it in a chart. So let's look at the last problem. It says 2 similar cubes have a side length of 3 to 7. Well, generally when I do this, no matter what, I'm going to make my EE chart. Just because I like to remember it and I like to see it there. So 3 to 7, I'm going to do this in my calculator just to show you how, again. I'm going to do 3 to 7. And I'm going to square it. When I square it, I get 9 over 49. Now I'm going to do the same thing, only this time I'm going to cube it. 3, 7, and the cube is under math. I'm going to hit 3 to cube it, and I get 27 over 343. So now let's read the problem. It says the volume of the larger cube is 175,616 centimeters cubed. What is the length of the side of a smaller cube? So this is going to probably be a little tricky, but we can do it. So first of all, how do I find the volume of a cube? So I brought up the formula from the formula sheet, and what's so special about a cube is that all the sides are the same. So it would be side times side times side, or side cubed. So if I look, the volume of a larger cube, so I can find the volume of the smaller cube by using my proportions. 27 over 343 equals, the larger one is on the bottom, 175, 606, and I'm looking for the volume of the top one. So from here I'm going to cross multiply. 343V equals 27, and I can do this in my calculator. 27 times 175, 616. And what do I get? 4741632. I divide by 343, and the volume of the smaller cube is 13,824. And what is so amazing about that is volume is just equal to side cubed. So side cubed is 13,824. Now to find how big a side is, I'm going to take the cubed root. When I do that, I can do that in my calculator. Under math, number 4 is a cubed root, and I can type in my answer, which I will, 13824, and I get 24. So the side length of the smaller is 24 centimeters.